Hello everyone, today we'll be talking about acid and bases in organic chemistry. So according to Arrhenius, the acid is a substance that dissolves in water to produce hydrogen ions, and for base, it is a substance that dissolves in water to produce OH. Example for that, if I have something like HCl, it will dissolve in water giving proton, which is a hydrogen ion, and Cl minus. For base, something like NaOH will dissolve in water giving Na positive and OH negative. We mean by the hydrogen ion, we mean by that either hydronium ion or H5O5 plus, because if you look at hydrogen ion is actually a very small ion. Once it comes to in water, it just combines with water, producing the hydronium ion, or one hydronium ion combined with the water molecule to produce the H5O2 plus. So in most organic chemistry, we don't have an aqueous solution. This is why Brønsted-Lowry proposed the other way of introducing acids and bases. In that case, the acid will be a proton donor and the base will be a proton acceptor. We don't have to have an aqueous solution, and the acid-base reaction is the proton transfer from the acid to the base. So the conjugate acid and base differs by pairs by the moving of the proton from the acid to the base. I have to remember one thing: in proton transfer, it transfer from non-bonding pair to the other atom. So I have atom with a non-bonding pair. This will move to the other atom. Conjugated acid and base is actually the other mirror of my acid and base. If I have something like this acid, HCl, it will dissociate into, I have so the proton will just move to the water and the Cl will be negative. In that case, the hydrogen chloride, which is an acid, will form what we call conjugate base. And the water, in that case, will be assumed to be base. It will, because it is going to accept the proton, it will form what we call conjugate acid. So the conjugate acid and base is actually the other way around from looking to acid and base. Now, if I have the same example and I want to just show the arrows of the moving charges or protons from acid to base, I have to remember one thing. I cannot draw the electrons moving from H to the oxygen, but the other way around. So if I have here, if I draw here the water, I have here 1, 2, 3, 4, 5, 6, 7, 8. I have 8 electrons around the water, and for HCl, I have the H and Cl, and I have 6 lone pairs around the 6 non-bonding electrons around the Cl, and in that case, 2 of the lone pair will move to that bond. Okay, so I have here an arrow will move in that side, and in that case I will have H and O and H. This means my proton will move to the water, and I will still have another two non-bonding electrons on the oxygen, plus the Cl in that case will have 1, 2, 3, 4, 4 non-bonding pairs around it. This means I will have here negative charge. Now for Brønsted Acids and Bases in absence of water, in that case, if I looked at this example, but this example doesn't contain any water, I will have the acetic acid and ammonia. They will react together to give me acetate ion, which is a conjugate base, and the ammonium ion, which will be considered as the conjugate acid. If I need to just to draw the arrows of the both acid and base, in that case, if I just break down my acetic acid, I will have here two non-bonding pairs of around the hydrogen, and I have the ammonia with the two lone pairs, and I have the three hydrogen ions. In that case, what will happen is a moving of those two lone pairs in that side, and my hydrogen will just move to that side. But you have to remember, you cannot draw. It's wrong to draw that the hydrogen will move here. We don't draw arrows for the moving of protons. We just draw arrows for the moving of the electrons, okay? In that case, I will have CH3, C double bond O, and O with a negative charge, because I have now two lone pairs and two lone pairs and another two non-bonding pairs, and by that I will have 1, 2, 3, 4, 5, 6, 7. So I have extra charge from my original charge, and I have my ammonia, which is NH. Okay, let me just explain this plus and positive, how I can know that this should be a negative and this should be be positive. So I have the format charge of the oxygen. I have oxygen in my actual state. Oxygen have 6 electrons around it, okay? In that case, if I looked around the oxygen, I just will count the, if I have bond, I will count only one electron in that side. So I have, in that case, I will have 1, 2, 3, 4, 5, 6, 7. I have 7 electrons. By that, I increased one charge, one extra charge, one electron from my format charge. So I will write it down above the oxygen as a negative. For the nitrogen, I started with nitrogen have 5 electrons. If I count now the format the charge around the nitrogen, so I have 1, 2, 3, 4. You have to remember, and if I have bond, there is one electron belongs to the H and the other electron will belong to the N. So I have 1, 2, 3, 4. So I have 4 electrons. So I started with 5, I ended with 4. This means I have still I have missed one electron, so I have positive charge. Okay. Now let's look at this exercise. Write these reactions as a proton transfer reaction. I have to know which is acid and which is base. I have also to recognize which is the conjugate base and which is the conjugate acid. You have to remember they are opposite. If I start with an acid, this means it's gonna be a conjugate base, and if I started with a base, it will be my conjugate acid. Okay, and I have to also to draw the Lewis structure for each one. As for the first one, so I have written here that water would be the base. Because it will accept a proton, and ammonia will be the acid because it will be the proton donor. But let me show you why I assumed that. If I try to draw the water like drawing it before, so I have here 4 non-bonding electrons around my oxygen, and I have here the H. Like the previous example, I told you those are 4 electrons. This means I have positive charge because my formal charge on the nitrogen is actually 5, and my formal charge around oxygen here 1, 2, 3, 4, 5, 6. Now, what will happen is one of those lone pairs will just move to this bond, so I will have the proton moving from the ammonia to the other side. So I will have here H, O, H, H, and I will have here the 2 non-bonding pairs, the 1 non-bonding pair, and I will have here the nitrogen. So I have 1, 2, 3, 4, 5, the same charge for the nitrogen, so there is no positive and negative. I can write here, but here 1, 2, 3, 4, 5, 5, 6. So 1, 2, 3, 4, 5. So I will write the extra one as a positive over the oxygen. So I moved here the non-bonding electron to that side. This means this is my base, and this should be my acid. and for that I told you my base will form on the other side conjugate acid, and my acid will form on the other side conjugate base. Okay, let's look at this example which I have ethanol. So I have CH3, CH2, and if I try to draw the oxygen, I will have two non-bonding pair plus nitrogen. I will have here hydrogen and hydrogen, and 1, 2, 3, 4. This means I have here negative charge. So I completed here with this. So these two non-bonding pair, because if you count 1, 2, 3, 4, 5, 6, 7, 8, because I have to satisfy the octet rule around the nitrogen. But I started with only 5 electrons, and I ended up here by 1, 2, 3, 4, 5, 6 electrons. This means I have to write down a negative above this nitrogen. What will happen? The transfer will happen from this side to that side, sorry, to this bond. So the proton will just move to the nitrogen. So I will have CH3, CH2, and I have oxygen with 3 non-bonding pairs plus. So if I count 1, 2, 3, 4, 5, 6, 7, this means I have here negative because I have 7 electrons around my nitrogen. And for nitrogen, I have here 3 hydrogens, and I will still have my 2 non-pairs, but I will, if I count the formal charge on my nitrogen, it's 5. So I don't write any positive or negative. So I started from that one which gave up protons, so this is my acid. And this one which accepts my protons, this is my base. This will be my conjugate base because it's the opposite to that one, and this is my conjugate acid, because it is the acceptor of the proton. Now what happens if I have 2 more than acceptor sites on my molecule? If I have something like acetic acid, I have here this oxygen which can accept the protons, and this one which can accept the proton as well. So if I draw it, I will just draw. So what happens? I can put this, so one of those charges can move here, and I will assume the other one to move here. So I will have 2 compounds, 2 possible compounds. One which I have the hydrogen move to that side, and in that case, if I count the formal charge around my oxygen, it will be 5. This means I have to draw down positive. And if my hydrogen move to the other oxygen, which is this one, I will have CH3C double bond O, and I will have here the H, and I have here the OH as it is. So now if I count the charge above my oxygen, 1, 2, 3, 4, 5, this means I have to do positive because my formal charge is less than what I started with. Now if I try to write the resonating structure of this one, so what happens? I have 2 possibilities. I have here the possibility that my double bond will move on that oxygen, and in that case I will have this structure CH3 and C double bond O H. If I just write it down here, so I will write down an arrow here. This means it will move. What will happen in that case? I will have this structure CH3 and COH with two non-bonding pair. In that case, my oxygen, this oxygen, can move one of its lone pair to that carbon, because the carbon now is missing one electron, and I will have this resonating structure. So I will have here double bond OH with 1, 2, 3, 4, 5. So I have here positive charge, and here I will not change this one. So those are the three resonating structures. You could see that either this double bond will move to my oxygen, and I will have charges around my oxygen, or my two non-bonding pair will move to that side, and I will have the double bond in that side. So the double bond is just resonating above the whole structure. But it's like, it's hard for this one to happen, because in that case you will have here positive charge near this positive charge, which is two adjacent positive charge and negative charge on the other side. So this is hard to happen. This is structure hard to happen, but the other way around, those three resonating structure is more, there is more possibility of those to occur. Now moving to this exercise, if I looked at guanidine, so I need to draw the structure of guanidine with the electrons around my of the electrons, bonding electrons and non-bonding electrons. So my guanidine structure would be like that. You have to remember, when you draw down your structure, you have to satisfy octet rule. This means if I count the electrons around my nitrogen, 1, 2, 3, 4, 5, 6, I'm missing 2, so I will write them as non-bonding pair. If I look here, 1, 2, 3, 4, 5, 6, so I will draw down two non-bonding pair, and here I have 1, 2, 3, 4, 5, 6, so 7, 8, I will have to draw my two non-pair. Now, if I reacted this one with HCl, if I draw this one plus HCl, in that case I have to just remember plus HCl. HCl usually is a proton donor, and what will happen, it will accept electrons, and in that case it may come from that side, because this is NH only, but those have 2 protons and those have 2 hydrogen, and this one have 2 hydrogen as well. So what will happen is a moving of those non-bonding pair to that side, and my proton will just move to the other side. So I will have this structure C, NH2, and here I will have NH2, and I will have here, I forgot to use double bond, so I will have it here again, and here I will have NH2. My 2 non-bonding pair is still here, my 2 non-bonding pair is still here, but here I don't have them, and I have instead 2 hydrogen, which means 2, 1, 2, 3, 4, I'm missing 1 electron, so I will write down positive charge on the nitrogen. And for the chlorine atom, like I said before, I will draw down the negative charge, because I start with 7 electrons, I ended up with 8 electrons. This means I have to represent it as a negative charge over the chlorine. Now what will happen, this double bond may just move around my structure. So it will move up here, because there is a positive charge on this nitrogen, and my 2 non-pair will just move on that side. So I will have this structure C, and I will have NH2, NH2, 1, 2, 3, 4. I have my carbon as it is, but here 1, 2, 3, 4, 5. This means it's also as it is, and this one 1 2 3 4, so I have to draw. It also can resonate, my other resonating structure can be the movement of my double bond back to my nitrogen, and in that case my two pairs from this nitrogen, so I will have here NH2, and I will have here C NH2, have here 2 lone pair, 2 lone pair, non-bonding pair, and I will have here NH2, and in that case I will have and actually I draw here 2 bonds, so I don't have to draw here the bonding pairs. So what happens, I will have this double bond, like as I've seen here, it moves to that nitrogen, or it may move to that nitrogen, or it may move to that nitrogen, okay? So it moves to that nitrogen. So I have 3 resonating structure. My fourth resonating structure is where I will have my carbon with NH2, 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 and in that case the 2 lone pair will be non-bonding pair will just stand here, and all my and I will have positive charge on my carbon. So this is the fourth resonating structure. This means I have 4 resonating structure for guanidine reacting with hydrochloric acid. So if I completed reading this one, does a proton transfer to guanidine occur preferably to one of the NH2? Usually this doesn't happen. It would prefer more the proton of the HCl. It would prefer more, this proton would prefer to move to this nitrogen first. Then what happened next is the resonating of the double bond over my structure. Okay? So proton, if I looked at this explanation, it says here proton goes to NH group because it is the most basic nitrogen atom. So this NH is actually my most basic nitrogen. This is why my proton would just prefer to go that nitrogen first. Then my double bond would resonate all over the structure, and I will have this 4 resonating structure. We've seen before that my non-bonding pair is moving to my other molecule. In that case, I will have here double bond. Let's draw this structure: CH3, CH, double bond CH, CH3. I have here butane, butene, 2 butene. And if it is reacting with HBr, if I draw the non-bonding pairs over my bromine, I will have here 3 non-bonding pairs. So if I try to draw the reaction between these 2, what will happen is the bromine HBr will give me the proton, which means it is the acid. And this will be my base because it's going to accept this proton. But I have to remember one thing. I don't have here non-bonding pair to move to my structure. And instead, I will have my double bond moving to the other molecule. And I will have this bond to move up on the bromine. So I have CH3, CH, CH, CH3. And in that case, it can come to that one or that one. And so I can have here the H of the HBr will come to that one, and I will have here positive charge because this is the most basic one, plus the Br. In that case, I have to draw the negative charge on that one because I have 1, 2, 3, 4, 5, 6, 7. So I start here with 2 butene, and I ended up here with secondary butyl cation. Secondary butyl cation. This exercise, write the equation. If I looked at this double bond, if I reacted this double bond plus HCl, in that case I will have HCl with the 3 non-bonding pair, and this double bond will move to the hydrogen and the bond will move just up here. So I will have here, you have to remember that the basic nature of this carbon almost equal to the basic nature of these carbons. This means my proton may come to that one or that one is the same. This means I have to write down both structure, CH2, CH3, and in that case I will write here positive, and I will add here the hydrogen, or I may have the other structure also, CH2 and C H from that side and H from that side and CH, and this will have the positive charge CH3. You have to remember I write down this positive charge because if you look down now around the formal charge around my carbon, 1, 2, 3, 1 for the hydrogen, because if I just will this hydrogen on that side, so I have this hydrogen. So 1, 2, 3. So I have 3 formal charge of my carbon. So I'm missing 1 electron. In that case, the other one. So I have these 2 compounds can form at the same time, plus the Cl, of course, with all non-bonding pair and negative charge. Now, if I reacted the cyclohexane with HCl as well. Now I have either this side, which I can add my proton, or that side, which I can add my proton. So the double bond will move from my structure. Let's write here the HCl. The double bond will move from this one to that one, and the bond here will move up to the chlorine atom. So my product will be, in that case I will have here hydrogen carbon, which is positive, and that one will have the proton, or I can have the other way around. So I can have the other structure, which I have here the 2 protons, they are the same, plus the Cl, which will have the negative charge because the formal charge increased 1. So by that we came to the end of our first video. Next time I will be talking about dissociation constant of the acid and base in organic compounds. Thank you and goodbye.